Hello guys, welcome once more to another video in our YouTube channel. So in this video we continue looking at the physics problems that features in the National Aptitude Examination into the first year of medical, odontostomatological and pharmaceutical training in Cameroon. In this video we focus on physics 2019 question number 23. So the question reads, a planet has a radius of 3/2 of that of the Earth and a density of 1/3 of that of the Earth. If a man jumps 1.5 meters on Earth, the approximate height he could jump on this planet is, so we have option A right up till option E. Okay, so if you're just joining us for the first time, make sure you like the video as you're watching, you subscribe to the channel if you have not subscribed, you turn on your notifications after subscribing, and you also comment what you feel about the video in the comment section. So you can also navigate through this channel to get other useful resources that can help you effectively prepare for your concours. So to solve this problem, we are going to bring in so many interesting concepts, and make sure you pay keen attention to the concepts I'm going to be explaining because they could help you in other problems. Okay, so I drafted the solution out, and this is how my solution looks like. First of all, I try to find the mass of the Earth because the mass of the Earth was not given, but I'm not going to find a numerical value of the mass of the Earth because if you are a student preparing for this concours, you should know the numerical value of the mass of the Earth provided it's not given to you. But I'm going to express the mass of the Earth in function of the universal gravitational constant, the acceleration due to gravity, that is the field strength G, and the radius of the Earth. So the gravitational force that exists between two massive bodies is what we call the force that exists between two massive bodies is what we call the gravitational force, and it is given by G, which is the universal gravitational constant, times the product of the masses divided by the square of the distance that is separating the centers of the masses. Okay, so generally if you're on the Earth, then the gravitational force is basically the weight. So doing this, the gravitational force between the man and the Earth is given by its weight. The weight is the mass of the man times the acceleration due to gravity, or the gravitational field strength, while the force normally is given by G times the mass of the Earth times the mass of the man divided by the square of the distance separating the center of the Earth and the center of the man, which is just the radius of the Earth since the man is on the Earth's surface. Okay, from here m can cancel on both sides and we can get the mass of the Earth as GRE squared divided by capital G. Now some other things we are going to involve is the volume of the Earth. The volume of the Earth is the volume of a sphere, alright, because the Earth is spherical. So the volume of a sphere is given by 4/3 pi radius cube. Since we are specifying that this spherical body is the Earth, then the radius becomes the radius of the Earth. Now, what about the density of the planet? The density of the planet is basically 1/3 times the density of the Earth as per the equation. But normally, density of any body is equal to the mass of that body divided by the volume of the body. So density is mass per unit volume. So it therefore means that the mass is going to be the density times the volume. So the mass of the Earth will be the density of the Earth times the volume of the Earth, while the mass of that planet will be the density of the planet times the volume of the planet. You're going to see where I'm going to. So we are now going to find the volume of the planet. So the volume of the planet is 4/3 pi the radius of the planet cube, because the planet is also a spherical body. So since we know that the radius of the Earth, the radius of the planet is 3/2 times the radius of the Earth, we are going to replace the radius of the planet here with 3/2 times the radius of the Earth. So doing that, we have 4/3 pi 3/2 radius of the Earth all cube. 3/2 cube gives us 9 divided by 8, and then 3 cube is 27, 2 cube is 8. So we are going to have here 27 divided by 8 times r8 cube, then times 4 on 3 pi. So simplifying, we just have 27/8 times 4/3 pi radius of the Earth cube. Now the quantity in yellow is just the volume of the earth. So the volume of the planet can be found in terms of the volume of the earth. So here we just see that the volume of the planet is 27 divided by 8 times the volume of the earth. Okay, now with that, we can easily find the mass of the planet. So the mass of the planet, which is the density of the planet times the volume of the planet, becomes the density of the planet is 1/3 the density of the earth, and the volume of the planet is 27/8 times the volume of the earth. So we have here is the density of the planet in terms of the density of the earth. Here is the volume of the planet in terms of the volume of the earth. 27 divided by 3 is 9, so we are going to have 9 divided by 8 times the density of the earth times the volume of the earth. But the density of the earth times the volume of the earth is the mass of the earth, as we saw earlier. So we have written the mass of the earth in terms of, we have written the mass of the planet in terms of the mass of the earth. Now we are going to find the acceleration due to gravity of the planet in terms of the acceleration due to gravity of the earth, that is the gravitational field strength. So the gravitational field strength from this very formula here, when m is going to cancel, or from this formula, the gravitational field strength of a certain planet is a is a mass of that planet. If you make g the subject, we are going to have m times capital G divided by r squared. But since the planet is the point of reference, then the gravitational field strength of that planet is the mass of the planet times the universal gravitational constant, is constant everywhere, divided by the square of the radius of the planet. Now we are going to find this guy in terms of the gravitational field strength of the earth, which is G. So since I have the mass of the earth as 9/8 times, since I have the mass of the planet as 9/8 times the mass of the earth, I'm going to replace it. I'm going to have here 9/8 times mass of earth times G. The radius of the planet is 3/2 times the radius of the earth, but we have to square. So when we square this denominator, we are going to have 9 divided by 4. But since it is in the denominator, then the denominator of it will go to the numerator. So we are going to have 4/9. So we are going to have 9/8 times 4/9 times MEG over RE squared. Now MEG on RE squared is definitely G of the earth. Alright, that is, if you want to look for G here, your G is MEG over RE squared. So this quantity here is small g, or G of the earth. Now 9 cancels 9 and 4 goes into it 2 times. So the gravitational field strength in the planet is half of that of the gravitational field strength of the earth. So G P equal to half G. Now we are going to use the concept of pressure. Pressure is mgh, because I need to, in fact, I'm introducing the height. All right, so the pressure on the earth's surface is going to give me mg times the height jumped by the man on the earth's surface. So I'm going to have the height jumped by the man on the earth's surface is 1.5 meters. So I replace he with 1.5, then my m and g will remain constant. This m here is the mass of the man, while g is the gravitational field strength on the earth's surface. Now the pressure in the planet is the mass of the man, because the mass of the man does not change, okay, no matter where he goes to. So the mass of the man, what changes is the height he's going to jump on that planet, as well as the gravitational field strength of that planet. So since we already have that the gravitational field strength of that planet is half times the gravitational field strength on earth, we are going to replace GP with half G. Then the height that a man is going to jump on that planet, we just represent it as HP. From the equality of pressures, we are going to have 1.5 mg is 3/2 mg equal to half times mg HP. From here, you realize that mg cancels mg, 2 cancels 2, and we are left with HP to be equal to 3 meters. So the height the man is going to jump on that planet, with respect to the fact that the radius of the planet is 3/2 times the radius of the earth, and the density of the planet is 1/3 of that of the earth, that height is going to be approximately 3 meters. So option B is correct. Tell me what you feel about this video. Don't leave this video without liking, sharing, and subscribing to the channel. See you guys in the next video.